Kia ora koutou, Reese here from QuickSense, and in today's lesson we're looking at simultaneous quadratics. Now, for simultaneous quadratics, while we could use we could normally use either the substitution or elimination method for simultaneous equations, it's going to be much simpler to use the substitution method. So what does that look like? Well, immediately I can see that y is up here by itself, and I'm given something to substitute for it. So let's do that. If y is equal to x squared, y plus 2x plus 1 equals 0. Now I can solve this like a normal quadratic equation. So x squared plus 2x plus 1. Knowing that one of the factors, when I factorize it, has to be 0, I can solve this for x. So what are the factors of 1 that add to 2? 1 plus 1, right? So x plus 1 times x plus 1. And we can write that differently. We can write it as x plus 1 squared. But this shows me that I can have two possible answers. In this instance, they happen to be the same. So x equals either x plus 1 equals 0, which is x minus 1, or x plus 1 equals 0, x is minus 1. So x equals minus 1. But I'm not done yet. Right, this is what x equals. But the question is asking for x and y. And what does y equal? Well, y equals x squared. And x, as we know, is -1. And this is why we have it in a bracket, because if you put this in your calculator, it'll come out with -1, because your calculator thinks you're doing does not equal -1 squared. It thinks you want to take away 1 squared, which is 1, giving you -1. The answer, I'll leave that there, the answer, -1 times -1, it's a negative times a negative, so it's a positive, is 1. So y equals 1, and x equals -1. Now, in the last example, we were given quite a simple substitution to do. In this one, it's not obvious, right? I could substitute for a or b by rearranging this. So this is my first equation. This is my second. By rearranging the second equation, I can have it either be a equals b plus 1 over 4, or b is equal to 4a minus 1. Now, because we already have this a squared, I don't want to substitute for a, right? I don't want to have to replace a. What I would prefer to do is to replace this b, substitute it for something in terms of a, right? So if b is equal to 4 lots of a minus 1, then substituting that into 1 gives me this here. 6a squared equal to 2 times b, which is 4a minus 1. I can expand that and then move it all to the left-hand side. So 6a squared minus 8a plus 2 is equal to 0. Now that it's equal to 0, I can start trying to solve this quadratic as usual. So because 6a, 8, and 2 all have a factor of 2, I can immediately divide both sides by 2, giving me this. Remember, 0 divided by 2 is 0. Now I have this position here. I multiply this 3 and this 1 together to give me plus 3. And I'm asking, what are the factors of 3 that add to -4? Well, because it's a negative number and it's the multiple itself is a positive number, I know they're both going to be negative. And -3 times -1 is positive 3, and it adds perfectly to -4. So I de-simplify. Oh, there should be an a there. and then minus 1 lot of A gives me this here. So factorizing these two first, the common factor is 3A. 3A goes into A squared, 3A squared A times, and goes into minus 3A minus 1 times. Okay, now looking at the second one here, minus A plus 1. Right, well, A plus 1. If I do that, we can see that this is different to this. Is there a way I can make them the same? Well, yeah, I can. Let's move over here. So 3A, get a bit more space. A minus 1 minus A plus 1 equals 0. Minus A plus 1, if I factor out negative 1, so I have negative 1 here. Well, how many times does negative 1 go into negative A? Well, it goes into it A times. And how many times does negative 1 go into 1? It goes into it negative 1 times. So now we can see we have this common factor here. So what's left when I factor out this common factor? This set of brackets here. And this allows me to start to solve for A, because either this here equals 0 or this here equals 0. So 3A minus 1 equals 0. Well, let's write that down. Then 3A equals 1, and divide both sides by 3. A equals a third. On the right-hand side, A minus 1 equals 0. A is equal to 1. So A is equal to a third or 1. They both satisfy this situation. Now the last thing we have to do, it's a bit of a longer question here. The last thing we have to do, we've solved for A, now we need to solve for B. So solving for A, well, what is B equal to? B is equal to 4 times A minus 1. So let's substitute in A equal to a third minus 1. Well, 4 lots of a third are 4 thirds, or 1 and 1 third minus 1 is equal to a third. If A is equal to 1, 4 times 1 is 4, minus 1 is 3. So we have these two options for what B is equal to. If A is a third, B is a third. And if A is 1, B is 3.